edition of final countdown. This is week 10, day 3. Let's get into work. Right. In the circuit shown, base current of the transistor is 100 microamperes. Remember, transistor is a current control device. So base current is the controlling current. And VB is 0.7, so silly current. If the current gain of the transistor is 100, then the voltage at C is going to be how much? So beta is given, that's IC over IB. Beta is given 100, IC over IB, 100 microamperes. IC is going to be how much? Cross multiply. 10,000 microamperes. 10,000 microamperes. That's here going to be micro minus 6 minus 3, 10 milliamperes. Now how do you find the voltage here? Think about the potential difference. 5 minus 0, potential difference there. That's going to be IC into 400 plus. IC into 400 plus. Voltage here. BC minus 0. BC minus 0. Voltage at BC. 5 is equal to 10 milliamperes times 400 plus VC. 4 plus VC. VC is 1 volt. VC is 1 volt. Answer number 2. VC is 1 volt. Answer number 2. Question number 2. In the circuit shown, R1, R2, R3 are of the order of few kilo ohms. An appreciable current can be found. An appreciable current can be found. So I think, so you can think of this as ideal diodes or silicon diodes. So here voltage is 0. Here minus 5, here voltage 0. Right. Think of this carefully. If current is going this way, forward bias, 0.7 drop. This is minus 4.3. Minus 4.3. Okay. So high potential, low potential. High potential, low potential, current will pass through. High potential, low potential, current will pass through. High potential, low potential, current will pass through. So if you look at this carefully, R1, R2, R3, all are current. So from here only I find it. So silicon barrier voltage is around 0.7. So 0.7 if I keep it there, then high potential, low potential, forward bias. High potential, low potential, forward bias. High potential, low potential, forward bias. So you have done. Water droplets drip at a constant rate. Water droplets drip at a constant rate from a tap as shown in the figure. The center of gravity of the system where the drops is most likely to be. Now, you can apply ratio theory because all these masses are equal. So the masses are equal. Look at this carefully. So here if I take these two masses, 1:1 ratio, total mass here is 2. If I take these two masses, 1:1 ratio, total mass here in between 2L. Here we have L. Now let me take this mass and this mass. Exactly half. 1:1. Exactly half. 1:1. Somewhere here. 4. Now what? 4:1 ratio. Center of gravity somewhere there. Correct answer is R. Correct answer is R. Okay, no? So you are applying what theory? Ratio theory. Okay. Moving forward. When the temperature theta of air inside a closed room is varied, temperature inside a closed room is varied. According to the curve A shown in the figure, its relative humidity is found to vary with time. According to curve B, so curve B is relative humidity. Curve A is temperature. Curve A is temperature. So don't forget these two graphs. Temperature, absolute humidity graph. Temperature, relative humidity graph. Absolute humidity graph. Temperature reduces, constant, then reduces. Here it increases, constant. This is your dew point. Dew point will take place. Here dew point. So if your relative humidity is increasing, temperature reducing. Relative humidity is reducing, temperature is increasing. RH is constant, that means that RH is going to be 100%. Right. So look at this carefully. Observe. Huh? Here RH is increasing. RH is increasing means temperature reducing. Correct. Here RH is constant. RH is constant. Look at this. Temperature is also constant. Temperature is constant. What else? Here RH reduces, temperature increases. So the rules are correct. Look. Corresponding variation of the absolute humidity. So all are straight line variations. So if you look at this, RH is increasing, so temperature reducing, RH increasing, temperature reducing, here saturation, huh? Here saturation, don't forget. So temperature reducing, RH increasing, H is constant. Can't be this graph, can't be this graph. Maybe one of these three. Right. Then what? RH is constant means H reduces. Saturation. RH is constant means H reduces. This graph is regular elimination. This one, we'll see. Then temperature increases, RH reduces. RH reduces means H is going to be one constant. So here if you look at it, if you look at 4 and 3, if you look at 4 and 3, now H reduces means RH is 100%. AH is increasing means temperature increasing. AH is increasing means temperature is increasing. But here T1, T2 temperature constant. So can't be this. Only possible solution is this one. Only possible solution is that one. So correct answer is answer number 4. Correct answer is answer number 4. Right. The figure shows the amount of heat absorbed by 1 kilogram of ice under each status when you heat from minus 50 to 100. So minus 50 to 100 means heating or absorption of energy is taking place. Right. So here I think the time is given, heat is given, and here temperature increase is given. Right. In kilojoules. So delta Q is equal to M ice delta theta. Delta Q here is 111 kilojoules. Mass of ice 1 kilogram. Specific heat capacity of ice. Change in temperature is 50. Simplify this carefully. 1000 divided by 50 is 20. 0.222 joules per kilogram per Kelvin. Joules per kilogram per Kelvin. 1220. Right. Next, fusion. Delta Q is equal to MLF. 333 kilojoules. 1 kilogram LF. LF is 3.33 10 to the power 5 joules per kilogram. Here specific heat capacity of water. Delta Q is MCW delta theta. I think already we have found the answer, answer 3. Answer number 3. Because here specific heat capacity of ice is not 110, 2220. But I'll just do this part and finish it off. 490 kilojoules. Change in temperature 100. CW is equal to 4190 joules per kilogram per Kelvin. Correct. So third one is the wrong one. A vessel of negligible heat capacity contains water of mass NO at room temperature. So vessel contains mass NO at room temperature 30 degrees Celsius. 30 degrees Celsius. When mass M1 of water 100 degrees Celsius. 100 degrees Celsius mass M1 is added to the vessel. So you are mixing lukewarm water. You are mixing boiling water with room temperature. The maximum temperature of the mixture becomes theta n, neglecting heat loss. The variation of theta n with N1 or N0 is best represented. So heat given M1 specific heat capacity 100 minus theta n, who is absorbing M0 CW theta m minus 30. So m1 over n0, that is theta m minus 30 divided by 100 minus theta m. So they are asking how the ratio will change. How the ratio will change. So you can do some basic substitution. If you look at this, they are given in 3 places. Theta m 60. Theta m 60. Sorry. Theta m 30, let's say. 30 minus 30 is 0. M1 over M0 0. So it can't be first one, can't be second one, can't be third one. First, second, third. They are asking the M1, M0 ratio, no? But there is a mass ratio there. So we'll ignore the 30 part. Huh? Sorry. We'll ignore the 30. We'll do the remaining. Right. Already there's a mass ratio. So we'll keep that. Theta m 60. 60 minus 30 is 30. 100 minus 60 is 40. M1 over M0, 3 over 4. M1 over M0, 3 over 4. So here, at 60 the ratio is more, can't be. At 60 the ratio is slightly less. At 60 the ratio is slightly less. At 60 the ratio is very less, can't be. At 60 the ratio is okay, we'll keep it there. Right. Then theta m is 90. 90 minus 30 is 60. Ratio is 6. 90 ratio can't be this. 90 ratio can't be this. Ninety ratio, 90 ratio can't be this. Most suitable answer is answer number 2. Most suitable answer is answer number 2. Right. Question number 7. Figure shows a space colony of radius 10 to the power 3 rotating about its axis at what angular speed must the space colony rotate. So the astronaut standing on the floor experiences the push on his feet equal to the weight on earth. Normal reaction equal mg. Centripetal force, mass into centripetal towards the center. Now we can't see it in a space colony, we don't know where mg is. So mg will provide the required centripetal force. M omega square radius. M cancel off. G is 10. Omega square radius 10 to the power 3. Omega square is 1 over 100. Omega is 1 over 10. 0.1. 0.1. Answer is answer number 1. Answer is answer number 1. Moving on. Question number 8. A charge point Q is placed at one of the corners. One of the corners. The electric flux through the surface ABCD of the cube due to charges. Now you must fully enclose this. So I'll draw the cube a bit smaller. Draw the cube a bit smaller. There you go. Here you have plus 2. So let us enclose this fully. Enclose this fully. Like this. Now from front it is closed. From back also closing. And now fully closed. Now how many surfaces like this do you have? 1, 2, 3, 4. 4 times 4. 4 times, sorry, 6. 24 surfaces. Flux through 24 surfaces. Sum of charges inside Q over epsilon naught. Right. Flux is a scalar. Flux through one surface. Q divided by 24 epsilon naught. Answer is answer number 4. So remember, you must fully endorse this charge, Gauss. In there are how many similar surfaces like ABCD? On one side 4, 6 sides in a Q, so 24. Flux through 24 surfaces, Q over epsilon naught. Flux through one surface, Q over epsilon naught divided by 24. Okay, right. A radio is powered by 6 1.45 batteries connected in series whose internal resistance can be neglected. 6 batteries are there. A single battery can provide a charge of 9600 coulomb. If the batteries treat the radio as resistance 270 ohm. 270 ohm. At a certain sound level, the number of hours the radio can be operated at this sound level is. So 1.5 volt, no internal resistance also, let's find the current in the circuit. Apply Kirchhoff. Sum of EMF equals sum of potential differences. Minus to plus, minus to plus, minus to plus, minus to plus. Add everything up, 1.5 times 6. Current in the circuit, I times 270. I is equal to how much? 9 over 270. 1 over 30 amperes. There. 1 over 30 amperes. So, Q is equal to IT. Now, one battery 9600 coulomb. Connection in series means if one gets weak, the other will work. 9600 times 6. Current 1 over 30 times 9. Now if you look at this, 9600 times 6 times 30, the coming seconds. How do you convert this to hours? 9600, 6 times 30, 3600 seconds. 0, 0, 0, 0, 6 times 1, 6 times 6. 6 times 1, 6 times 5. 0, 3. 480 hours. 480 hours. Sorry. Now, if a single battery can provide a charge, so the charge traveling through this is the same. Charge traveling through is the same. So, be careful here. You might make that error. It's not 9006, 96, 96, 96. Charge at a particular instant will be 9600. So here, multiplying by 6 is wrong. Don't multiply. There is a reason. Now when you are connected in series, the amount of charge passing through will be the same. So whether one battery is working or whether 5 batteries are working, the basic idea should be what? The same. So 9 volt is given by the battery, main batteries. So right now, So don't multiply this by 6. That's a cardinal error people make. The reason is all are connected in series. The same charge should pass through. Okay? So remember that mistake. Don't make that mistake. You might make that mistake. Don't make it. So here multiply by 30. So this 480. Don't get it. It's wrong. The reason is what? What's the reason? If I multiply the Coulomb by 6, that means every time a battery weakens, the amount of charge in the circuit will not reduce. Whatever happens, the total charge in the circuit should be the same. Okay? So basic logic is correct. No? The logic should be correct. So this you divide by 3600. 0, 0, 0, 0. 6 times 6, 6 times 5. 6 times 1, 6 times 1, 6. 80 hours. 80 hours is more suitable. More suitable means correct answer is 2. So remember this very carefully. When you connect batteries in series and they are telling you a single battery can provide 9600, every battery the charge on it in this whole circuit, only a single charge is passing through. Single charge is passing through. So current is constant, charge should be constant. If one battery reduces, the other should balance and somehow give the same charge. So here you will get the time 80 hours. Here you will get the time 80 hours. So very important question. You can write a small sentence there. Write a small sentence there. Even though 6 batteries are connected in series, even though 6 batteries are connected in series, the amount of charge passing through it will be the same. The amount of charge will remain the same. Right. Okay. Question number 10. Right. In the circuit shown, E represents the EMF. E represents the EMF. Negligible internal resistance. These are good questions. R1, R2, R4. R1, R2, R4 are finite resistances. B is the ideal voltmeter. Ideal voltmeter means current is going to be 0. If the value of R3 varies from 0 to infinity, so 0 to infinity, yeah? 0 to infinity, which of the following terms correctly predicts the voltage when R3 equals 0 and R3 equals infinity? I think I have done that. When R3 equals 0, 0, that's what? Non-resistant wire. You are short circuiting it. If you are short circuiting this, current will come this way and go through that. So the moment you short circuit, I'll draw it here itself. You all, when you analyze it, draw it separately. I'll draw it here itself. Current will go through this. Anyway, ideal current won't go. That is the current will go. So short circuit. Short circuiting here, current will pass through. What will be the voltage? What will be the voltage reading? So no current will go across this. So here resistance 0, voltage also will be how much? 0. Voltage 0 they are represented easily. Voltage 0 will be represented easily. Think carefully. Here short circuit. Here short circuit. Therefore current will go through this. It won't go through the large resistor can't go through voltmeter, it will go through that. This voltage is across R4. So no voltage there. Next is R3 equals infinity. R3 equal infinity means open terminal. Open terminal. What do you mean by open terminal? Open terminal means anyway current won't pass through. Open terminal, this is not there. Current won't pass through. Then current will go across this and that. I'll mark it red. Will go across this. Then voltage here, same. So what's the voltage across that? Voltage is R1 times total voltage divided by addition. R1 plus R2. Correct answer is answer number 3. Correct answer is answer number 3. You can see one step how I am taking this. Question number 11. A thin walled cylindrical vessel is floating in a lake. At time t equal naught, a small hole is made at the bottom of the vessel and water is allowed to flow into the vessel at a constant rate. So the vessel immerses with constant velocity, is going down with constant velocity. If h1 is the difference in height, normally, listen to this very carefully. If the outer level and inner level height is constant, sinking will not take place. The moment h1 starts reducing, sinking will occur. So remember, the rule is very simple. If the difference in the outer and inner layer is constant, sinking will not take place. You can make a note there. If the difference in the outer and inner layer is constant, if h1 is constant, sinking will not take place. So here, as long as h1 is constant, so what happens is, if I show it here, let's say it's sinking. Inner outer layer constant. Now from the layer outside, H2 has become 0. But still, what? H1 is constant. H1 is constant. Right. What are they saying? So H1 is constant. H1 is constant. H2 can be 0. H1 is wrong. H1 is constant. H2 has reached here. That's also wrong. H1 is constant. H2 has reached 0 first. So most suitable answer, correct answer is going to be answer number 2. From this diagram it's clear. Outer inner layer H1, but H2 has become not 0. So they are asking you, best represents the variation of H1 H2 with time. Small object of mass m is suspended in L. Here tension is there. So T cos theta balances weight. T sin theta provides centripetal force. So if you simplify this, T cos theta balances the weight. T sin theta equals mv squared over radius. Radius is L sin theta. Divide one by the other. Tan theta equals mv squared L sin theta mg. Mn cancel off. V square is LG tan theta sin theta. LG tan theta sin theta square root. Answer is answer number 1. Answer is answer number 1. Question number 30. Read. Figure shows the variation of force exerted by the flow on a field when it is jumping upwards. The force increases from a value which is equal to the person's normal weight. So if you are going to jump up, you must apply a force more than the weight. So area under the weight has no meaning. Area under the weight will not give impulse. If you are just standing and waiting with time, area under the weight has no meaning. But area above the weight has meaning. So here you can say 0.1 plus 0.4 divided by 2 into perpendicular distance. 1430 minus 650. 780. Child is jumping up. Mass of the child 65 kilogram. 65 into V initial 0. Simplify this 0.5 times 390 65 V. V is 195 over 65. Velocity will be 3 meters per second. Velocity will be 3 meters per second. There you go. So what's the main idea here? Area under the weight has no meaning. Area above the weight will give you the required impulse to jump. Question number 14. A source of sound S moving with velocity Vs emits a sound wave of frequency F0. Doppler effect question. An observer O moving with a velocity V0 is shown in the figure. Determine the frequency of sound as F dash. So source moving away. Source moving away. Observer moving behind the source. So F dash here is velocity of sound with respect to observer. Velocity of sound with respect to observer. Sound is coming from the source here. Sound with respect to observer V minus V0. Velocity of sound with respect to source V plus Vs into actual frequency F0. So look at this. Vs is large, V0 is small. So 300 minus 2280. 300 plus 60, 360. Bottom is large. It should be small. First one is small. Vs is 20, V0 is 60. 300 plus 20, 320. Take Vs, velocity of sound is 300. 320, 240. Bottom is V. This may be correct. Third one. Minus 20. Vs means opposite direction. 280 at the bottom. 360. This is also okay. Vs is minus 60. 240. P0 minus 20. 320. Also large. Correct. Vs is 60. 360. Minus 20. 320. So these one. So if you look at it, obtain the basic relationship here. Let's see. BS is 20, 320, 60, 240. Which of the following statement is true? So velocity of the source 20. So here 20, 320. Velocity of the observer 60, 240. 240 over 320 means F dash is smaller. So correct ratio. I mean F dash is going to be smaller than F naught. I will check whether the ratio of the answers put is correct. Right. Yeah, it's correct. Okay. So these three statements are true. What is VSC 60? VSC 60 means going this way. What do you mean by V naught is minus 20? V naught minus 20 is that way. So if you represent it, velocity of sound with respect to observer. You will be very careful here. Velocity of sound with respect to observer. V minus 20. Velocity of sound with respect to source. Velocity of sound with respect to source. V minus 60 into F naught. So I have drawn the fourth one. Huh? So in this case, 300 minus 20 is 280. 300 minus 60 is 240. These is larger. Correct. PS is minus 20. V naught is minus 60. Next one is third one, B minus 60, B minus 20 in the F naught. 240 over 280. 240 divided by 280. The ratio is smaller, wrong. This one 20 and 60. VS is 20, 320, 240. Can you got the ratios correctly there? VS is 20, V naught is 60. Right. VS is 20. VS is 20. V naught is 60. So addition, velocity of sound with respect to observer. Velocity of sound with respect to observer. Velocity of sound with respect to source. Think carefully. V plus V naught. Here it's going to be 360, 320 greater than 1. So these are wrong. So out of this, the most suitable answer is going to be answer number 4. Most suitable answer is going to be answer number 4. Okay. Right. So be a bit careful with the directions. Question number 15. For real images produced by convex lens, real images produced by convex lens. Values of the object distances, image distances are marked. Which of the following best represents the correct pattern when corresponding U and V? So here, object distance, image distances are equal at certain locations. So here if you look at it, then the most suitable answer will be answer number 4. Why? There you always a place where the object distance and image distance are same. Correct answer, answer number 4, reversibility of light. An ideal gas undergoes a cyclic process as shown in the figure. Consider the following statements. A. Over a complete cycle, net work is done by the gas. Clockwise cycle, net work output. Anti-clockwise cycle, net work input. This is larger, so net work output is there. Statement A is correct. Over the complete cycle, net heat goes out. Wrong. Work output means work input. B wrong. Heat input. Temperature of the gas remains unchanged throughout the cycle. Wrong. Only correct statement is answer A. Only correct statement is answer A. Right. Moving forward. A small metal ball is suspended by insulating thread. Carries a charged tube is inserted gradually into an uncharged conductor. Now this is called Faraday's ice pail experiment. So what happens is they are asking you charge of the outer surface. The moment it enters here, charge goes to the outer surface. Whatever happens inside, outer surface charge will remain the same. From T1 till the end remains the same. Which means correct answer is answer number 5. Correct answer is answer number 5. So whatever happens here, if you look at it, the moment here, if you bring a charge plus Q, outside plus Q, here also plus Q, here also plus Q, here also plus Q, here also plus Q, here it's going to be a plus Q, here it's going to be 0, here it's going to be 0, coming out 0, outer will be same. Right. Figure shows a glass plate dipped in liquid. If the glass plate makes an angle theta with the horizontal, they are asking you exactly what's the angle with the liquid. So here, where the liquid touches the glass, draw an tangent. Angle made by through the liquid. So the angle made through the liquid is your angle of contact, which is 180 minus theta. Question number 19. Figure shows a bicycle wheel rotating with large angular velocity omega. So what happens here is, here there is angular velocity acting, angular momentum acting, and because of the weight, there is a torque acting. So angular momentum will always try to meet the torque. So it will rotate around without falling. So axle will rotate about the vertical axis through A, but AB remains almost horizontal. Right. Question number 20. Question number 20. A is a uniform metal rod length L mass N. Rod B is bent to form which is identical to A. Point mass is placed. So whenever you have uniform rods, subdivide this into small masses. That's the correct way to do this. Subdivide this into smaller masses. Subdivide this into smaller masses. If you subdivide this into smaller masses, delta N, then you can nicely see this correctly, you will be able to see this. What are they asking you? They are asking you to find the gravitational force on M by A. So here there is a force. Here there is a force. Here there is a hose. Here there is a hose. Look at this carefully. Cos components remain, sin components will cancel off. Cos components remain, sin components cancel off. If you look at this carefully, larger distance, smaller force. Smaller the distance, larger the force. Here, always distance are same. I'll mark it a different color. Here, force is same, whatever happens. Again, cos components are there, sin components are not there. Sin components will cancel off. So looking at this, what can you say? Capital G M over R square, that's your normal situation. But here now it's going to be delta M and you are taking cos components, so it's going to be smaller. But distance is going to be the same. So here if you look at it, distance is same, mass, so cos components are there. FB is going to be larger than FA for sure, right? Distances are getting larger, forces are getting smaller. Angle is also getting large, so cos component is a small value. Are they ever equal to this? Never. Capital G M simple M R square is always larger, which means correct answer is answer number 4. So all you do is think larger distance, smaller force. Smaller distance, larger force. And cos components are there. Cos is theta small means cos force is large. Everywhere distance same. Only cos components are there. So distance is actually same. Cos components are there. Here distance is also large. Cos components are there. These smaller than that. And they can never be equal to this because it's delta L. Right. Structured essay. Structured essay. Look at this carefully. There is a moving coil galvanometer. A moving coil galvanometer with coil resistance Rg produces full scale deflection I naught passing through it. Write down an expression for the voltage V naught. V naught is equal to I naught Rg. I naught Rg. Right. When a voltage V1 which is less than V naught appears across the galvanometer, producing a deflection theta, and if theta M is the full scale deflection, write an expression for V1 in terms of. So all of you all know it's a linear scale. V naught proportional to theta M. V1 is proportional to theta. V1 over V naught, theta over theta M. V1 is V naught times theta over theta M. Theta over theta M. Part C. This galvanometer is to be converted to a voltmeter giving full scale deflection voltage V2, which is larger than V naught. If you are provided the superstar R1, show how you would connect it. So galvanometer is going to be Rg. Connect another resistor R1 in series such that the terminals will give you a voltage V2. Terminals will give you a voltage V2. So you connect the shunt resistor in series. Connect the shunt resistor in series. Write an expression for R1 in terms of V2 I0 RG. Total voltage is equal to full scale deflection I0 RG plus R1. V2 over I0 minus RG equals R1. Very good. V2 over I0 minus RG is R1. If RG equals 20 ohm, I0 is 10 milliampere. Find the value of the resistance R1 required to give a full scale deflection 1 volt. So looking at this equation, we can work. V2 over I0 minus RG, that is R1. Voltage required 1 volt. Full scale deflection 10 milliamperes. Galvanometer resistance 20 ohm. R1 can be found. R1 is 100 minus 20, 80 ohm. 100 minus 20, 80 ohm. Right. Also calculate values for resistors R2, R3, converting to 10 volt. So V2 over IG minus RG is equal to R2. V2 is equal to 10 volt. IG is 10 milliampere. Galvanometer resistance is 20 ohm. That won't change. That is equal to R2. R2 is equal to 980 ohm. Similarly, V3 equals IG minus RG, that is R3. 50 volt, 10 milliamperes. RG is 20, R3. 5000 minus 20, 4980 ohm. 4980 ohm. Okay. Using the resistance value calculator, draw a circuit with a multi-range voltmeter. So actually you can do this. RG you can mark. Here you can put resistors. Now you can select. So if I name this A, B and C, what are the voltages? 980, 80, no? 80, 980, 4980. 80, 980, 4980 ohm. So here you can select it. A terminal gives you 0 to 1, 0 to 10, 0 to 50. 0 to 1 volt, B terminal, 0 to 10 volt, C terminal, 0 to 50 volts. So here is your multi-volt meter. Multi-volt meter using a 3-way switch. If this voltmeter is used in a 0-10 volt range to measure voltage, 5 volt appearing across 2000 ohm resistor, would you expect to obtain the actual value? Now here there is a 2000 ohm resistor. You connect the voltmeter here. 0-10 volt means 980 ohm, 20 ohm. Will you actually obtain the correct answer? Answer is no. Current will go through the voltmeter as well. And you are measuring the voltage across the effective resistance. Not 2000, not 1000. 2000, 1000 divided. So that is about how much? 2000 multiplied by 1000 divided by the addition is 3000. That's about 666.7. Answer. You are right to answer that. Answer is no. We will obtain the voltage across the effective resistance. We will obtain the voltage across the effective resistance acting due to 2000 ohm and 1000. Acting due to 2000 ohm and 1000 ohm. Right. Electricity essay question. Electricity essay question. Right. Figure 1 shows a circuit diagram of a Wheatstone bridge V0, where V0 is the voltage supply. So that when the bridge is balanced, show that when the bridge is balanced. What do you mean by bridge is balanced? Voltage at A equals voltage at B. Right. So what is the voltage at A? So what I normally do is I ground this point, easy. Voltage at A is from the ground point A. That's your mistake. Don't take from top, from the ground point A. R3 times total voltage. Here V0 means total voltage, here also V0. So R3 times V0 divided by R2 plus R3. What's the voltage across B? Again from the ground point. R4 times total voltage divided by the addition R1 plus R2. When the bridge is balanced, VA equals V. Simplify this. R3 V0 divided by R2 plus R3 equals R4 V0 divided by R1 plus R2. Simplify carefully. V0 cancel out. First multiply. R3 R1 plus R4 equals R4 R2 plus R3. Carefully open brackets. R3 R1 R3 R4 R4 R2 R3 R4. These two cancel out. So you can say R1 R3 equals R2 R4. So R1 over R4 equals R2 over R3. R1 over R4, R2 R3. Now, done. Suppose R1, R2, R3, R4 simple R, that means bridge is balanced, is now made unbalanced by introducing a small resistor simple R into arm R3. So R3 is R plus R. So that under this condition, voltage is VR divided by 4R plus 2R. Note that capital R is greater than R. The above expression reduces to VR over 4R. Right. So now you can redraw this. No? Here, here you go. R1, R2, R3, R4. R1, R2, R3, R4. R1, R2, R3, R4. Terminal A, terminal B. See if they mark that correctly? Yeah, A and B. Now, Same as earlier. Here voltage is V naught. Here voltage is V naught. Find it quickly. Voltage at A from the ground. R plus simple R V naught divided by addition with the branch. R plus simple R. R plus simple R V naught divided by 2R plus simple R. What about the voltage across B? Voltage across B. Capital R times V naught divided by R plus R. That is equal to V naught over 2. What is the voltage drop? What is the voltage drop occurring across AB? VA minus VB. R plus simple R V naught 2R plus simple R minus V naught over 2. Common denominator 2 times 2R plus simple R. Cross multiply this. 2 V naught R 2 V naught simple R minus 2R minus V naught simple R. It will simplify the relationship. Simplify the relationship. 2 V naught R. These two cancel. V naught R 4R plus 2 simple R. 4R plus simple R. Here they are telling R is greater than simple R. So 4R plus 2R is approximately 4R. So voltage difference between A and B is V naught R over 4 capital R. V naught R over 4 capital R. Found. You can see I am just using potential divider method. Nothing else. I am using potential divider method. Next up. Next one. The resistance R2 is reduced to R minus R. So now what? Here I count this easier. Terminal A, or it should be opposite, I think. Yes. Terminal A and B should be opposite. Here R and R. Terminal A and B. R minus R, R plus R. So R2 is reduced to R minus R. Now find the voltage across A and B. Here V naught means here also V naught. Voltage across A, potential divider, voltage here from the ground level. R plus R, V naught divided by addition. R plus R, R minus R. R plus simple R, V naught. 2 capital R, V. Here voltage across V. Here R. R times V naught divided by R plus R. V naught divided by V naught divided by 2. Find the potential difference. PA minus VB. PA minus VB. R plus R. V naught over 2R. Minus V naught over 2. V naught over 2. Sorry. The addition, right. Simplify this. 2R. R V naught. V naught simple R. Minus V naught R. V naught simple R over 2 capital R. VA minus V. Power. Okay now? Right. Show that the voltage is double. V naught R over 4R. So right. V naught R over 4R times 2 is V naught R over 2R. Therefore, voltage across AB has doubled. Voltage across AB has doubled. Right. Such increase or decrease of resistance occurs. For example, when metals are subjected to elongations or contractions by the application of external forces. If the volume and resistivity of metal strip do not change, when elongated, show that the resistance increases. So here, what is there? Area is A, length is L. Elongated means increase. Now area is A2, length is L2. So resistance here, rho L1 over A1. Resistance here, rho L2 over A2. Also don't forget, volumes are same. A1 L1 is A2 L2. So if I divide this equation, R1 divided by R2, L1 divided by L2, A2 divided by A1. If you look at this, R1 over R2, L1 over L2. What is A2 over L1? Again L1 over L2. R1 over R2 equals L1 over L2 whole thing square. L1 over L2 whole thing square. So from this we can say resistance is proportional to L square. Length increases, resistance increases. Length increases, resistance increases. Right? Good question. Read. What are they saying? An accelerometer is constructed to measure the accelerations of objects by fasting vertically an insulated rectangular rod AP to the upper inner surface of the box. Attached to the mass here. There's a mass here. Two metal strips P and Q of resistance R are fixed on either side, RR. Ends of the strips are connected to two arms of the eastern bridge. Top and bottom. There are R2 and R4 over there. When the box is placed in an accelerating object and the acceleration changes, causing the rod to bend. Now what has happened? Here when it accelerates, maybe accelerating backwards, it will bend, accelerating forwards, bend backwards. Here length will reduce, here length will increase. What could happen to the lengths of the stitch P and Q? P, length increases. Length increases means resistance increases. Q, length reduces. Right. If V naught equals phi, magnitude of the fractional change in resistance are the same. Is equal to 1 over 100. Find the voltage generated between A and B. Look at this carefully. I'll do it. Voltage between A and B is V naught R over 2 capital R. V naught R over 2 capital R. Okay. What are they saying? Fractional change in resistance. Now, one resistance was initially R, became R plus simple R. So, fractional change. Fractional change in resistance. That is change in resistance over initial. Simple R over capital R. Another resistance was R became R minus R. What is your fractional change? Fractional change is going to be R minus R over R. Again simple R over R. So simple R over R V naught divided by 2, right? So what are they doing? I'll do it here itself. If V naught is equal to 5, fractional resistance 1 over R, 5 here 2, how much? Potential difference between A and B, 5 divided by 200, 0.0, 500 divided by 2, 0.025 volts. Right. Find the voltage. How would you calibrate such an accelerator? How do you calibrate? Division in the voltmeter, each division in the voltmeter, there is a corresponding acceleration. Each voltmeter, corresponding acceleration. Each corresponding acceleration. So if you can calibrate it like that, for each voltage, there is a corresponding acceleration. Each voltage, corresponding acceleration. Like that you can calibrate the accelerometer, right there. For each potential difference, there will be a corresponding voltage. Right. Thermal physics, gas law question. Figure shows a hot air balloon inflated with ambient air at atmospheric pressure 10 to the power 5 Pascal. The inner volume of the balloon is 830 cubic meters. 830 cubic meters. Treat air to be an ideal gas in all your calculations. So that's a normally we do. Determine the mass m of gas inside the balloon in the above temperature. So we can take PV equal LRT atmospheric pressure 10 to the power 5, 830, mass over molar mass. Molar mass of gas 30 gram per mole convert to kilogram. R is 8.3. Temperature 300 Kelvin. Temperature 300 Kelvin. From this, if you simplify, the mass you will get around 1000. Around 1000. So if you do the basic calculation, times 1 times 10, 83. M1 is 83,000 divided by 83. 1000 kilogram. Around 1000 kilogram. Then 1000 kilogram. Right. To lift off, the air inside the balloon should be heated. Modern hot air balloons heat the air by burning propane. Propane is burned. The propane is stored in compressed liquid form in lightweight cylinder position in the balloon. If the temperature of the air inside the balloon is raised to T Kelvin, write down an expression for mass M2 of air remaining inside the balloon. Inside the balloon at temperature T. So we are increasing the temperature by T. Pressure of the heat remains the same under atmospheric conditions. Under atmospheric conditions. So here PV equals nRT. Pressure same, volume same, remaining mass into molar mass 30 gram convert to kilogram. R is 8.3. Temperature increase by T or T? 2T. Simplify this. So here 0 0 cancel. 8.3 times 1, 8.3 times 10. 30, 2 zeros divided by T. That is the mass. 3000 divided by T. 3000. Yeah. 30 grams. So if you put in grams, that's a different story. Kilograms. Yes, this is what you will get. Right. Okay. Calculate the upthrust acting on the balloon due to air outside. Neglect the volume of the material of the balloon and all other contents. So upthrust equal B density of air into G. 830 cubic meter. Have they given you the density of air? Density of air. Are you going to find it? Hence find the density of air. So density of air is equal to mass of volume 1000 divided by 830. 100 over 83 kilogram per meter cube. But here you must at least keep for 1 decimal place. 1 decimal place. 1.2 kilogram per meter cube. So that you can use here. 100 divided by 83 times 10. 10,000 Newton. 10,000 Newton. Right. If the total mass of the balloon excluding that of the hot air inside is 246. Determine the value of the temperature which the air inside the balloon should be heated just to lift off. Hence find the mass M2. Be careful. Here weight M2G. Upthrust is 10,000. No change. Here 246G. Just to lift off. Just to lift off. 10,000 equals M2 plus 246G. 1000 M2 plus 246. M2 246 250 means 750. 246 means 754 kilograms. 754 kilograms. You all know the connection now. M2 is equal to temperature 3000 OT. 3000 divided by T. 754. 3000 divided by T. T is equal to 3000 divided by 754. We'll just look at this calculation again. Pascal 830, M2 8.3. 0, 0 cancel off. Right. 8.3 times 10 here. 8.3 times 10. 10 to the power 6. 10 to the power 6, 10 to the power 3. 3 will come. I made a calculation error. I think I made a calculation error. We'll have a look at this. So here, I'll erase and do it. Hmm. 8.3 times 100, let's say. 10 to the power 5. 830 into 30 grams convert to kilograms into 8.3 into T. 8.3 times 1 into 100. You can't have this small error. Here there is error. Cross multiply 10 to the power 7. M2 is equal to 30 20 another 20 over T 3 10 to the power 5 T. Now right. So this is erase it. Sometimes when you calculate you will realize. No, I realized it later. So here when you substitute, so calculation error here. So when you are doing it, if you dash it, quickly go back and correct it. Simple. These are not. So you substitute to get the answer. Right now, let's go with soon. So no issue, because here you will realize the mass, the temperature curve is small. Now divide and see. This divided by 754 will get you a particular answer. Let's see how much. Here 3000, oh sorry, 300,000 divided by 754. 397.9. 397.9 Kelvin. But determine the value of T. 397.9. So 397.9. Approximately 398. Right. Assuming that the heat released by burning propane is absorbed only by the air inside. Estimate the heat supplied in this process. Take the mean temperature of air leaving as this. 300 plus T. So delta Q is equal to mCp delta theta. So mass of the gas inside, or mass of the air inside the balloon $754. Specific heat capacity 1000. Change in temperature (300 plus) temperature leaving 398, no? Approximately, divided by 2 minus 300 Kelvin. 754 10 to the power 3. How much? 698 over 2. 349. 300. 49. If I multiply 754 multiplied by 49, 36.946 megajoule. So this is the amount of heat absorbed by the air. Heat absorbed by air. This is the air inside, air remaining inside balloon. So remaining inside balloon means, do I need to take this? Think carefully. Assume that the heat released by burning propane is absorbed only by air inside the balloon during the liftoff. Estimate the heat supplied in this process. Take the mean temperature of air leaving the balloon to be. So I am giving heat. Heat is absorbed by the air remaining and the air going out. So two things are absorbing. So the amount of air going out you can find out. How much? Amount of air going out. So amount of air which was there, 1000 kilogram. Now remaining 754. That means 246 has gone out. Clear? 246 has gone out. The remaining is 754. 246 has gone out. So air or heat given, understood no? Simple logic. So here there are two parts. Heat absorbed by air remaining inside. Air remaining inside, of course, no need to take average. Directly we can take, like it's remaining inside. So here 398. No need to take the decimal place. 398. So if you multiply here, 754 multiplied by 98. So here you will get, simplify it, 73.892 megajoule remaining inside. Then heat absorbed by the leaving gas. There was gas leaving also. Heat absorbed by gas leaving. Think logically. That is going to be delta Q. Mass is 246 kilogram. Specific heat capacity 1000. After this you can take the average. 300 plus 398 over 2 minus 300. Let's see how much. If you multiply 698 divided by 2, 349 minus 300 multiplied by 246. 12.054 megajoule. So what are they asking you? They are asking you heat release is absorbed by the balloon inside during liftoff. Estimate the heat supply. So total heat supply. Total heat supply will be the addition of these two. 73.892 megajoule plus 12.054. 12.054 plus 73.892 85.946 megajoule. 85.946 megajoule. Okay, right. Amount of heat liberated when 1 kilogram of propane is completely burned is 87.5 megajoule. Determine the mass of propane. So mass of propane, I have used 85.946. 87.5 megajoule per kilogram. I get my answer in kilogram. Divided by 87.5. Less than a kilogram. 0.98 kilograms. Approximately 1 kilogram is okay. Okay? Right. So, gas problem, be careful even here when you are doing calculations, simplifications, be careful. One small simplification, you might get stuck, but come back and check. From here you can see, this is a good question. So, use the experience. When you are heating something, gas is going out. Heat is being absorbed by the gas going out and the gas remaining both. So, gas remaining directly you can find. Gas going out, use the average. Initial, final, average. And then addition of both will be the total heat absorbed. And this of course is easy. Per kilogram, how much of propane, joules. From there you can find the required mass. Okay, right. So this concludes week number 10. We have completely done the 2008 paper. So if I do a small analysis of what we have done, I told you from this week onwards. So 2008 A-level paper, all 60 MCQs done. All 60 MCQs done. All the 4 structured essay done. Essay, mechanics question done. Waves question done. Properties of matter done. Fields question done. Thermal question done. Electricity question done. All these completed. So far, week number 10, what have we done? 2000 done. 2001 done. 2002 done. 2003 done. 2004 done. 2005 done. 2006 done. 2007 done. 2008 done. So these to get you all working. How many MCQs? 60 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 540 MCQs done. 1, 2, 3, 4, 5, 6, 7, 8. For 8 weeks, we did how many structured essays? One structured, one essay. So here we did every day one structure. So 3 days, 3 structured. There. So 8 weeks, 3 structured each. 24 structured essays. Up to this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus, today you have done all 4 structured, 28 structured. Essay. Every day we did 1 essay for 8 weeks. 3 days a week, so 3 essays. 24 plus. Today we have done 1, 2, 3, 4, 5, 6. Altogether 30 essays. So how many MCQs you have done? 540 MCQs. 28 structured essays. 30 essays. Done and completed. Okay. So now next week also same. Next week also it will be 60 MCQs, all 4 structured, and look at the amount of essays, 6 essays. And after the 15 paper, add the electronics questions as well. Yeah. Okay. So the only question we are not doing here is the electronics question and the matter and radiation question. That was after the 12th or 13th paper. Right? Okay. Right. So by now, full paper you can do. Full paper can do. That is also very important confidence. Exam November, August, September, October, November. 4 months before the exam, you can do 60 MCQs, all 4 structured essays, and how many essays? 6 essays, without any problem. Which means you are at a very good level. Okay then, keep working. Meet you all next week with the 2009 A-level paper.